Hi, guys. Welcome back. In section 7.4, we take a look at some of the historical observations of Jupiter. We could go all the way back to Babylonians, but we're going to start with the very first person who looked at Jupiter with a telescope. This was early in the year 1610, about January 10th or so. And Galileo, in a certain sense, Galileo got to pick a lot of the low hanging fruit in astronomy because although there's some debate about whether or not he had the first telescope, which is unlikely, he was the first person to turn a telescope to the sky and then write down what he saw. And you can see a page out of his book, or a copy out of his book. And the big circle here represents Jupiter, of course. And then the smaller stars represent the points of light he saw going around Jupiter. Uh, if you look at these over the course of an evening, over the course of half an hour, you might see them move, you might not. Sometimes you'll see one pass behind Jupiter, in front of Jupiter, and then they appear to disappear, or it gives the effect that the moon is disappearing. Galileo couldn't see a lot of that because his telescope wasn't good enough. But what he could see is that the position of these points of light changed every evening, and that some evenings there were more. Here you can see there's four of them, here there's four of them. Some evenings there were only two of them, right? In this case, there were three of them. And he came to the conclusion that these objects were orbiting Jupiter, which was a big deal because up until that point, everything that people saw in the sky appeared to be orbiting around the Earth. Um, one day later, this gentleman, Simon Marius, observed the same moons. Now, there's debate about whether he plagiarized Galileo and so forth. But what's ironic is that although Galileo gets credit for discovering these moons, we don't use the names that Galileo gave them. We use the names that Simon Marius gave them. So Io, Europa, Ganymede, and Callisto were the names that Marius used. At the time, it was kind of a big deal, partly because we were discovering brand new things, but partly because a lot of people in Europe, including the Catholic Church, which in 1610 was very influential yet, believed in a geocentric model of the universe. And here's a beautiful picture of that, where you've got the Earth at the center, and then you've got I don't know if you can see this very well, but Mercury, Venus, I think that's the Sun, Mars, Jupiter, Saturn, and so forth, going around the Earth. That's understandable. It does seem, if you look at the night sky, that everything is going around us. Retrograde motion of superior planets is a little bit of a trick to explain, but people had worked out clever ways to make even retrograde motion make sense with the Earth at the center. Over here you have the heliocentric model, and one of the things that happened is when Galileo saw these 4 points of light moving around Jupiter, and when he concluded that they had to be orbiting Jupiter, that was the first time in human history that we'd seen anything that was not orbiting the Earth. And that lent a little bit of credence to the idea that the Earth is not at the center, that the Sun is at the center. And that's modeled right here. About 50 years, in the 1660s, 50 years after Galileo reported seeing he called them the Cosimo stars after Cosimo de' Medici, the person who was basically paying him, his benefactor. 50 years later, Giovanni Cassini had a superior telescope. And Cassini's telescope was good enough to see bands across Jupiter, to see Jupiter's great red spot. If you're really paying attention, you'll notice that in most of the images you see in this chapter, the great red spot is in the southern hemisphere. Here it's in the northern hemisphere. And you might ask yourself, does it move? Or is it something about the images that's different? You can see Cassini's telescope right here. That was the style of the day. People made longer and longer telescopes to get more and more magnification, to be able to see more and more detail, right? if you are an astronomer, one of the things that gets a little tricky is as you magnify an object more and more, it becomes trickier to follow it in a steady way through the night sky. Now, a modern telescope will have an electronic drive that will follow the stars as they go across the sky. Cassini obviously didn't have anything like that, and so they would build these big towers. And anyway, Cassini was able to make some pretty good observations. These are his drawings, replications of his drawings, of course. He observed bands and spots on Jupiter. He observed the red spot moving across Jupiter, and so he was able to take a guess at Jupiter's orbital period. Now we fast forward in time. Jeepers, this has to be 300 years. Excuse me. Yeah, no, 300 years, about 310 years. Pioneer 10 was launched in the 1970s, and it flew by Jupiter. You can see it right here. That gives you a sense of the size of it. And here you can see December 2nd, it was here. December 3rd, it had crossed the orbit of Callisto. On December 3rd, it crossed the orbits of Ganymede, Europa, and Io. Here it is on December 4th. And what's interesting is this. This is called a slingshot. When you have a satellite that comes in close to the planet and then whips around the planet and goes off in a different direction, that's called a slingshot maneuver. And Pioneer 10 was the first satellite in the history of the human race that successfully completed a slingshot maneuver. What this picture on the right side is not giving you is a sense of the three-dimensional nature of this. We're taking a bird's eye view looking down, but if you could flip the picture upright so that we were in this plane, what you would see is that I believe Pioneer, I might be making this up, but I feel like Pioneer was coming up out of the plane over here. NASA realized that this was a good way to do two things. One, it was a good way to pick up some speed. Technically, you could also bleed off speed, but NASA generally uses these things to pick up speed. I shouldn't say that. Going to the outer solar system, NASA uses this slingshot maneuver to pick up speed. The other thing it does is it means that you can see more than one planet. So with a little bit of, well, a lot of advanced planning, you can slingshot past one planet, which will then send you off to another planet. And if you slingshot around that one, you can get sent off to yet another planet. And that is exactly what happened with this Voyager spacecraft in the mid-70s. Maybe it was late 70s by the time it got to Jupiter. Voyager 1 went past Jupiter, then I believe it also went past Saturn, and it may have even made it into the ice giants in the deep solar system. Voyager 1 discovered a couple of interesting things. First of all, it discovered volcanism on Io. That's a picture of a volcano erupting on the surface of Io. It also discovered Jupiter's moons. This is the very first picture ever taken, of Jupiter's rings. So you can see the rings over here. Say, what's all this goofy looking stuff here? Well, if you look at it for a bit, you'll notice that there is a repeating pattern, right? And it turns out these are star trails. But because the spacecraft was wobbling, it had about a 78-second wobble. The star trails have that odd pattern to them. The black dots are just a background to give, NASA put it up there to help calibrate images, I guess. So now we move forward into the 90s, step forward in time about 20 years. Here's the Galileo spacecraft, about the same size, right, as the others. Galileo, here's just a stunning close-up picture it took of the moon Europa. Galileo was actually orbiting into Jupiter, so Galileo didn't go anywhere else, right? Pioneer 10, I believe, has left the solar system. The Voyager may have just left the solar system, but Galileo was orbiting Jupiter in the Jupiter system for several years, and then it was crashed into Jupiter. The reason it was crashed into Jupiter is that NASA didn't want the spacecraft eventually, right, getting into some kind of an orbit where it would crash into Europa, because Europa might have living organisms on it, and they didn't want anything from the satellite interacting with anything on the surface of Europa. Today, there is one spacecraft going around Jupiter, and its name is Juno. You can see Juno's got this odd, highly elliptical orbit where it passes very close to the surface of Jupiter and then goes way, way out, and then passes very close to the surface of Jupiter and goes way, way out. Why? This represents Jupiter's magnetosphere. These are radiation belts, and there is intense radiation rate in here. Galileo passed through it a couple times and actually had some of its electronics damaged by this radiation. The idea with Juno is that NASA is trying to sneak Juno inside those radiation belts. A result of that is that we get these just stunning close-up pictures, high-resolution pictures of Jupiter's surface, and here's one of the Great Red Spot. We're also getting nice pictures of the north and south pole of Jupiter. So Juno's currently in orbit. There are a couple of spacecraft that are scheduled to be launched in the next few years. One of them is called JUICE. It's from the European Space Agency. It's scheduled to launch in, I think, 2022 and will arrive at Jupiter 7 years later. That's one of the challenging things with these spacecraft is you've got a lot of downtime while you're waiting. Now there are things you can do. There are gravitational slingshots that are generating data as you pick up speed to get to the outer solar system. But it's not uncommon. In fact, I would say it's typical. From the time you sit down and say, we want to propose a mission to Jupiter, you write it up, you fund it, it gets funded, you build it, you launch it. By that whole process typically takes about 2 decades. And so these things eat up entire careers of people working on them. It's a slow process. So that is our current state of exploration on Jupiter. One final thing here, this is kind of interesting, I think, is that what people are really interested in now are the moons. Europa, Ganymede, and maybe even Callisto. Europa and Ganymede are interesting because they have subsurface oceans where there could be organisms living. Callisto is interesting because if people ever live in the Jupiter system, we would be living on Callisto.